Okay, this is optimization problem number 12, part 2. We left off with this formula that d squared equals 1/4 minus x squared plus x to the fourth plus 4 minus 4x plus x squared. Yes, that's a 4, not a y. Simplifying that one more step then, we get d squared equals 1/4 is the only constant. Negative x squared and positive x squared will cancel each other out. We have an x to the fourth here. Excuse me, 1/4 wasn't the only constant. We have a positive 4 here, a negative 4x here. So by simplifying this just a little bit more, we get that d squared is equal to x to the fourth minus 4x plus 4 and 1/4. Or 4 and 1/4, since this is the same as 16 over 4, it's same as 17 over 4. So I'm going to write it like that to begin with. And d, if we want to get it by itself, take the square root of both sides, would equal plus or minus the square root of x to the fourth, 4 again, minus 4x plus 17 over 4. Okay. And then what we need to do is take the derivative of that. Before we do that though, I'm going to make this a little bit simpler. Instead of saying the square root of all that, I'm going to say x to the fourth minus 4x plus 17 over 4, the whole thing to the 1/2 power, which is the same as taking the square root. That way I can use the chain rule when taking the derivative and get that the derivative of this function is 1/2, bring down the 1/2, multiply by what's in the parentheses, x to the fourth minus 4x plus 17 over 4. This pen does not like writing 4s or plus signs. All to the negative 1/2 power. But then we also have to multiply by the derivative of what's in the parentheses, which would be 4x cubed minus 4. And since it's an optimization problem, we're going to set all of this equal to 0 and solve. So 0 equals, since this is all to the negative 1/2 power, this is all going to go into the denominator with a 2, and the 4x cubed minus 4 is going to stay in the numerator. And on the denominator, we're going to have 2 times, really, the square root of x to the fourth. Again, fourth minus 4x plus 17 over 4. Zoom that a little bit. Okay. When we're solving this, remember, we're either going to set it the derivative equal to 0 or find where the bottom is undefined. The bottom would be undefined when this quadratic is equal to 0, or anytime this quadratic is a negative value. For instance, if we start with a negative number, it's possible that we could get a negative value, but when you take it to the fourth power, it's going to be positive. So first of all, let's just worry about the numerator being equal to 0, because that's pretty simple to solve for. Again, running out of time in this podcast, so we're going to go to a third one. I'm going to pause this for a second. We'll go to the third one.